Hello and welcome to this video lesson. In this video lesson we will be looking at surface area and volume of spheres. Okay, here's our sphere, and our sphere has a radius of r, so I'm going to label this as r stands for the radius. And given that the sphere has radius of r, its volume can be calculated by the equation 4 over 3 pi r cubed. You can also write this as 4 pi r cubed over 3. And its surface area can be found by the equation 4 pi r squared, which is just 4 times the area of a circle. Now, in this video, we're not going to go over why the equations are as they are. There, you can look at other videos to see the derivations of these, but we're just going to look at how we can use this set of information to find the volume or radius of a sphere given set of informations. So let's do a few examples. The first question asks us to determine the volume and surface area of a sphere with a radius of 3 meters. Alright, try pausing the video, try to look at the approach that you're going to take with the question, and then resume the video to check the answer. Alright, so to solve this question, we know that our radius is equal to 3 meters. We're trying to find the surface area and the volume. So the equation for the volume is 4 over 3 pi r cubed. So looking at the equation, this is a constant value of pi, and the radius is given to us as 3. So to find a volume, we just need to plug in the 3 here and substitute this value into the r value here. So I get my volume as 4 over 3 pi, my r value is 3, and then I'm going to cube that value. 4 over 3 pi, 3 times 3 times 3 is 27. I can simplify this a little bit. 27 divides by 3, and I get 9. And I could have done that earlier as well, but I just took the steps instead. So I get 4 times 9 times pi. 4 times 9 is 36. So I get 36 pi. And this could be my answer. So this would be an exact answer. And I can also plug this value into my calculator. So I can, on my calculator, I can simply go 36 times pi and get an approximate value. So when I plug it into my calculator, I get volume is approximately equal to 113.097. And usually I leave my answers in 3 significant figures. So with 3 significant figures, this is my first, second, and third significant figures. And after the third significant figure, my fourth one is a 0, so I don't have to round this up. So I can write my final answer as approximately 113 meters cubed. And I'm just going to put a box around this answer. For the surface area, I'm going to use the equation again. So for the equation of surface area is 4 pi r squared. I am going to plug in or substitute the r value of 3 into this equation. So I will get 4 pi times 3 squared. And I will get 4 times pi times 9 using BEDMAS. And I'm just going to put this in bracket just for good form. Now, what I have is 4 times 9, which is 36, and I get the pi, so I get 36 pi again. Look, it's very similar actually. You can see that the surface area and the volume of a sphere which has a radius of 3 is actually the same value. They're not the same thing because the surface area shows the area or the amount of material we need to make the sphere, whereas the volume is the space the sphere takes. So if the sphere is hollow, then there is 36 pi meters cubed of space of empty space within it. So the volume, similar to last time, so I don't have to put this in my calculator again because I'm going to get the exact same value, will be 113 meters squared. And make sure that your units are correct. So for surface area, our unit is meters squared or centimeters squared, whereas in volume it's meters cubed or centimeters cubed. The second question says to determine the diameter of a sphere with volume of 140 meters cubed. So pause the video, think about how you're going to approach the question, try to write the formulas down, and then once you're finished with the question, you can come back and check the answer. Alright, I'm going to write down all the information that I have. So I know that the volume is equal to 140 meters cubed. And I am trying to find the diameter. And if I put the equation of volume down, 4 over 3 pi r cubed, we can see that if I put in the volume here, this is a constant value, this is a constant value, and I will have one equation and one unknown, and my unknown would be the radius value. And if I find a radius value, I can find a diameter because I know that the diameter is equal to 2 multiplied by the radius. So my approach will be to find the radius first and then multiply that by 2 to get the diameter. So I have the volume equation. I am going to substitute this volume of 140 into this equation over here. So I will get 140 is equal to 4 over 3 pi r cubed. Now, I'm trying to isolate for r cubed. I know that r cubed is being multiplied by pi, multiplied by 4, and divided by 3. So to isolate it, I'm going to do this step by step. So first, it's being divided by 3, so I'm going to multiply both sides by 3 so that I can get rid of this 3 from the denominator here. So multiply both sides by 3. I'm going to put it in square brackets so that you can see that these are the steps. And I will get 3 times 140, which is 420, is equal to 4 pi r cubed. Okay, so now my r cubed, which is right here, is being multiplied by 4 and pi. So to isolate for r cubed, I'm going to divide by 4 pi. So divide both sides by 4 pi. And this side cancels out. And I will be left with r cubed is equal to, and I'm going to use my calculator for this. And when I divide it on my calculator, I will get r cubed to be approximately 33.4. And there's more significant figures, but I'm just leaving my answer in 3 significant figures for now. Now, note that when you're doing this on your calculator, there's a really big common mistake that happens. So a lot of students put it as 420 divided by 4 pi. And what ends up happening is, for using BEDMAS, your calculator will do 420 divided by 4 first, and then it will multiply it by pi, which is actually incorrect. So the way you want to put it on your calculator is 420 divided by brackets 4 pi. And when you do it this way, your calculator will multiply 4 times pi first, which is right here, and then it will do 420 divided by the value. So make sure you put this in brackets when you're doing this. This is a very big common mistake. Now, once you have this, you know that r cubed is equal to 33.4, but we don't know what r is. So the inverse process of cubing is cube rooting. So I will write that here. I'm going to cube root this side, and I'm going to cube root this side. And by doing this, this side becomes r, the left side becomes r. And on the right side, I have to use my calculator to do this. Depending on your calculator, there's different ways of doing this. So sometimes you have the button 3 square roots of a value, and then you can do 3 square roots of the answer from last question, or last part of your step, and you will get an answer. Sometimes you have something which is called n square root x, and if you're doing it this way, you have to, depending on the calculator again, sometimes you have to press 3 n square x button, and then the answer from previous one. So when I'm talking about answer, I'm talking about this value over here, because we want to use the exact value instead of a rounded value of 33.4. So depending on the calculator, again, you might have to do this, or you might have to do this. If you have a TI Inspire, to get to that point of getting to this step, you have to press the math button first. So find the math button in your calculator, and then once you find it, you can find cube root of a value. Now, an alternative way to cube rooting, which is one of my favorite ways of doing it because it's so much quicker than going through all the menu on your calculator, is once you have this value, you can simply on your calculator press previous value. So actually I will do it on the side here. You can just do 33.4, or your answer from previous one, which has more digits, to the exponent 1 over 3. Just make sure that when you're putting the exponents, you are actually putting this inside brackets. And once you do that, you should get the exact same value, because cube rooting is equivalent to raising the power to the exponent 1 over 3. So once we do it on our calculator, I'm going to use my previous answer and cube root it. I should get 3.22 given in 3 significant figures. Now the answer has more significant figures, but again I'm just leaving my final answer in 3 significant figures, and my unit for this is meters. Now another side note here, and I want to cover this because it's a little confusing to just give you this set of information and say you can raise it to the power of 1 over 3 and it will just work. I just want to show you how this actually works. So if I have r cubed is equal to a value, let's say value of x, if I raise both sides to the exponent 1 over 3, if you remember exponent rules, if I have power of power, I would multiply their exponents. This side there's just one power, so I will leave it as this. So Here 3 times 1 over 3 is same as 3 over 3, which is just 1. So on the left side I will get r to the 1 is equal to x to the 1 over 3, or a number to the exponent 1 is just itself, so it will just becomes r is equal to x to 1 over 3, where x here is the same value that we had over here. So if we have a question where it says r cubed is equal to, for example, 33.4, if we take all these steps, it will end up being that r is equal to 33.4 to the exponent 1 over 3. Alright, now that we have explained why this works, we have our r value, but we haven't answered the question yet. The question is asking what is the diameter of the sphere. So to find the diameter, I have to multiply the radius by 2. And I'm going to use my answer from the last question, which was 3.22. With more significant figures, it was 3.22117. Multiply it by 2, and I should get approximately 6.44 given in 3 significant figures. And the unit for this is meters. And I'm going to put my answer in a nice box. Now, the next question says the surface area of a sphere is 64 pi meters squared, and we want to determine its volume. So they give us the surface area, and they want us to find the volume. So think about how you're going to approach this, and try it out, and then watch the video to see the answer. Alright, so we're given the surface area on this one as 64 pi. So we're given as 64 multiplied by pi instead of just a value 64. And so instead of rounding a value, we give it in terms of pi. And it's meters squared. We want its volume. To find volume, we need a radius. So we also need a radius at some point. So let's write down the equation of surface area. Surface area is equal to 4 pi r squared. You can see that if we use this, we know that surface area is 64 pi. We can substitute it in. And then we will have one equation, one unknown, so we can solve for radius. Once we find the radius, we can plug it into the volume equation and find the volume. Alright, so in this equation, we know that surface area is 64 pi, and that is equal to 4 pi r squared. We want to isolate for r. R is being multiplied by 4 pi, so to cancel those out, I'm going to divide both sides by 4 pi. These cancel out, and I get r squared is equal to 64 divided by 4, which is 16. It's nice when we get round numbers like this, so I have to square both sides, and I get r is equal to plus or minus square root of 16, which is equal to plus or minus 4, because square root of 16 is 4. And since length is positive, r has to be bigger than 0, and therefore r is equal to 4 and not negative 4. So I'm just going to box this. Even though it's not my final answer, it's nice to have the radius. And now I'm just going to plug that into my volume equation, which is just equal to 4 over 3 pi r cubed. So now I get 4 divided by 3 multiplied by pi. My r value is 4, and I'm going to cube it. I'm going to use BEDMAS. 4 over 3. I'm going to do the brackets first. 4, and the bracket says 4 cubed, and 4 cubed is equal to 64. So I'm just doing the inside the brackets first. Now I know that I have 64 multiplied by 4 divided by 3. And if I can just write that as a fraction, and my answer as an exact solution would become 256 over 3 pi. And my unit is meters cubed. Now, I didn't have to leave my answer as an exact value. I could have just done an estimation. I could have just gone from this step all the way to this step really quickly. So if I plug this into my calculator properly, I should get my answer as approximately 268 meters cubed, and this is again 3 significant figures. Now, looking at some of the steps that you need to show with these questions, first of all, understanding that the surface area equation is this. So this is kind of a method mark or a reasoning mark. Plugging in the values correctly and solving for radius properly. Those could be 2 method marks, and coming up with the proper radius value here as an accuracy mark. And then using the proper equation. So this is for equation, a method mark for proper values or plugging in the proper values, and finally for getting the proper answer. So you can either get an exact value or you can get an approximation. And make sure if you are getting an approximation, well, it really depends on your school and your teachers, but in our classes, usually we leave the final answer in 3 significant figures when it's an approximation. Alright, this question says, if the volume of a sphere is 36 pi meters cubed, determine its surface area. So the last question had given us the surface area and it asked for the volume. This one has given us the volume and is asking for the surface area. So think about how you're going to approach this question, try it out, and once you're done, you can come back and check your answer. Alright, so the volume is 36 pi. We need the surface area, and to find the surface area, we need the radius. So I know my volume equation is 4 over 3 pi r cubed, and in this equation, if I have the volume, I have 4 and I have 3 and I have pi, but I don't have the radius, so I have one equation, one unknown, and I can solve for that r value. Alright, so the volume is 36 pi. I'm just going to substitute the value in. I get 4 over 3 pi r cubed. I am going to isolate r cubed, I'm going to divide both sides by 4 pi. The pi's will cancel, the 4's will cancel, pi here will cancel. This is so nice. So I get 9 is equal to r cubed over 3. Now, again, I'm still trying to isolate for r, which is right here, and it's being divided by 3 right now. So to get rid of that, I will multiply both sides by 3. And I will get r cubed is equal to 27. So I have to cube root both sides. And I'm looking for a number that multiplies by itself twice to give me 27. And you can use your calculator, but if you think about this, you should get r is equal to 3. as your answer, because 3 times 3 times 3 will give you 27. Okay, great. So now I have my R value. I'm going to box it, and I'm trying to find my surface area, and my surface area equation is 4 pi r squared, and I will get 4 times pi times 3 times 3, or 3 squared, or 3 times 3, and I will get 4 pi, 3 times 3 is 9, and I will get 9 times 4 is 36 pi as my exact solution. And write this, box it. Actually, I need units, so I can't box it yet. So I have to say 36 pi meters squared. And if I put this on my calculator, I will get surface area is approximately equal to 113 meters squared. This is very similar to a question that we had done previously as well. So the steps you would have to show for a question like this would be understanding that you have to use the volume equation to find the radius as an accuracy, and method marks for plugging it into proper equation and doing proper procedures to get to that R value. And once you have that R value, plugging it into the equation, making sure that the numbers are correctly plugged in, and finally getting a final answer either as an exact value or exact answer, which is 36 pi, or an approximation. Alright, our final question says that Ashley has a cylindrical container with radius of 1 meter and height of 1 meter. She wants to purchase basketballs for her gym class. What is the maximum number of basketballs that she should purchase to fit in this container? Okay, think about how you're going to approach this question, try it out, and once you're done, come back and check your answer. Okay, let's draw this out. So there's a container, and it has a diameter, actually radius, of 1 meter, and height of 1 meter. And we want to fit in a few basketballs in there. So let's say, just trying these randomly. But these basketballs themselves have a diameter of approximately, oh, it doesn't say. So diameter, we can research this, but a diameter of a basketball is approximately 25 centimeters, which is equivalent to approximately 0.25 meters. And to figure out how many basketballs we can put inside this container, we can find the total volume of the cylinder, total volume of the basketball, and divide the volume of cylinder by the volume of the basketball to see approximately how many you can fit in, and that would be the maximum number, assuming that there's no gap in between. And obviously there's going to be gaps in real life, so you have to account for that in your final decision. So to start this off, we know that the volume of a cylinder is equal to pi r squared multiplied by its height. We know that the radius of the cylinder here is equal to 1. So I'm going to plug in that value, and we know that the height is also 1, so I will also plug in that value. And once I put it in, I know that 1 squared is 1, 1 times 1 is 1, and 1 times pi is pi. So I will write my final answer in terms of pi for now, and you can put an approximation of 3.14 if you want, but I'll just leave it as pi for now. Now, for the sphere, which is the shape of a basketball, we know that the diameter is 0.25 meters. Make sure that you change the unit to meters, because if you plug in centimeters and then you have to change units later, but if you change the diameter into meter right away, you will have a little bit less work later. So if the diameter is 0.25, that means the radius is equal to diameter divided by 2. And once I do that, I should get 0.125 meters as the radius. You can also write the exact value of this, which is actually equal to 1/8 meters. So you can either use the exact value or you can use the decimal. In this case, I'm actually going to plug in the 1/8 in my equation just to follow the exact numbers, and let's put that in. So volume of the sphere is equal to 4/3 pi r cubed. So 4/3 pi, I will plug in 1/8 cubed as my radius, and I will get, once I multiply everything together, so you can put this on your calculator. I'm just doing this multiplied by this and leaving the pi as is for now. And if I do that, I will get 1/384 pi as my volume of the sphere. Now, since it might be a little difficult for some of the students to understand exact values, I will also write the values or approximated values of each. So pi would be approximately 3.14, and the volume here would be approximately 0.00881, or 3 significant figures. It's just 818. So you could go from here, so just plugging in the value to getting 3.14, and here you could just do 4 divided by 3 times pi times 0.125 cubed, and you should be able to get this value over here. Now, to find the maximum theoretical values of basketballs that we can put in to this cylinder, and if you actually think about this, this is a pretty giant cylinder with radius of 1 and height of 1. The height isn't that much, but the radius of 1 means that the diameter is actually 2 meters. That's a height of a really, really tall person. So it is a really big cylinder. So let's look at how many, theoretically, how many balls we can fit into this cylinder. So to find total number of basketballs would equal to the volume of the cylinder divided by volume of the sphere. And I will get pi over 1/384 pi. And if I do this, I will get 384. If you put in the approximated value from here, you could also do the same thing. So I'm just going to write also equal to 3.14 divided by 0.00818. And if you have the exact values from your calculator, so the exact value of pi and the exact value that you calculated here, so if you go back into your previous steps on your calculator and check them out, and if you plug them in, you should get approximately 384 as well. So both way you should get a very, very close answer to 384. So 384 basketballs can fit into this giant cylinder if there were no gaps. Obviously, there are going to be gaps. So just to be safe, it's not a good idea to buy 384 basketballs. Maybe 300 to start with. And then if you can fit any more basketballs, you can add a little bit more in. So again, this set of information will give you an idea of kind of a starting point, but you have to use your common sense and understand that there are going to be gaps, and because of those gaps, we can't fit in that many basketballs into this cylinder.